Hello everyone and welcome to the CloudScale Environment. CloudScale Environment is an application for analyzing cloud-based systems. It consists of 4 separate tools: the analyzer, the extractor, the static spotter, and the dynamic spotter. To learn more about each tool, press Learn More here. Now I will exit the intro page and show you the workbench. As you can see, the workbench is split into 3 different parts: the CloudScale Explorer, the workflow diagram, and the place for the editors. Inside the CloudScale Explorer, I currently have 3 different projects: the test project, Hadoop MapReduce, and the minimal example. Now let's take a quick look at the CloudScale Environment project. The CloudScale Environment project consists of 5 separate nodes: the analyzer, extractor, static spotter, dynamic spotter, and scale-DL models. The first 4 nodes represent our 4 different tools that are used inside the CloudScale environment. Let's expand, for example, the analyzer node. We can see here our minimal input alternative. The minimal input alternative is also represented inside the workflow diagram. We can see it here. So if we expand our minimal input alternative, we can see our input models. Those are also represented inside the workflow diagram. We can see our configurations. We have 3 different configurations: the normal configuration for measuring the response times, the capacity configuration for measuring the capacity of our system, and the scalability configuration. Inside the results node, we can see our results for the normal configuration, the capacity, and the scalability. We can double click every node inside the CloudScale Explorer to open the editor. For example, if you would like to see the repository model, we can double click and the editor opens up. If we double click the input alternative editor opens up, and here we can also see our input models. We can here right click every model and open the diagram, for example. So here we can see only one node. This is our reverse engineered system of the minimal example project. By double clicking the configuration alternative editor node opens up, and here we can edit our parameters, for example, measuring points, monitors, service level objective, and so on. So now I will show you the workflow diagram and how it can be used. The workflow diagram represents our tools and how they are connected. For example, here we have the extractor section. The extractor section consists of the input alternative subsection, the configuration subsection, and the results. The results of the extractor are the repository and the system model, as you can see here. The tools are connected with the dashed and continuous lines. The dashed lines represent requirements that are optional. The boxes, which has the shape of an arrow, represents actions. So double clicking the arrow, the wizard opens up. Apart from the tools and how they are connected, we can also see the validation statuses. Right now, all our alternatives and models are perfectly valid. So when something is wrong, the section is colored in red, and instead of the green icon here, we can see the red icon with exclamation mark. And then we can hover the mouse over it and we can see where is the problem and how we can fix them. Now I will exit the workflow diagram and show you how a simple application can be analyzed using our CloudScale environment. Let's start by creating a new CloudScale environment project. Press File, New, and select New CloudScale Project. Type in name and press Finish. We will start by using the extractor. You can see it here inside the workflow diagram. Let's create the new extractor input alternative. We have three different options how to create the alternatives. We can go File, New, Other, and here select the appropriate wizard. Or I think the easier way is to double click Create New Alternative here, or clicking the plus button inside the workflow diagram. I will select Create New Alternative here, and I will create new extractor input alternative. Inside the workflow diagram, we can see our input section of the extractor, and it is colored in red. Let's look what is wrong. Project is missing, so we have to select our input project. I have already imported our minimal example project. You can see it inside the Project Explorer, the minimal project. Here is the source code of our very basic application. To import the Java project inside the Project Explorer, you can right click and press import and then select your desired Java project for the analysis. So we have to select, here we have our extractor input editor, and on the upper right corner we press the three dots button to select our minimal project and press save. As you can see, our input section, input alternative is valid and the configuration is already created. You can open the configuration by pressing the configuration buttons here inside the input editor, or we can double click inside the configuration node and double click basic configuration. Here we can see all the parameters for producing the models from the source code, for clustering, merging parameters. We have advanced metrics here, so the user has an option to fine-tune all those parameters and produce the repository and the system model that is optimized for further analysis. But right now, I think the default parameters will work, so just press the Run button. The operation has completed. We see here success, and we can press here the results, and we can see our results. Those are the model repository and the system repository. Now the next thing we would like to do is analyze our minimal project application with the static spotter and see if we will detect any anti-patterns. First, I must inform you that maybe not all the results will be correct, because after producing the repository and the system model with the extractor, we have to specify the service effect specifications here. with the actual measurements. But this step is a bit time consuming, so I cannot show you the whole process inside this short video. So we can see inside the workflow diagram that the extractor result is connected with the static spotter input section, and this indicates that the results can be imported directly into the static spotter input by pressing the import action inside the workflow diagram. Here we can see the import wizard. Select import extractor results. Next, type in the alternative name and press finish. So now here we have our static spotter input alternative. We can see our repository and the system model. Press the button configurations to open the configurations. And here we can see the configurations for the static spotter. I think the default configurations are okay, so we can proceed by pressing the run button. Okay, our operation completed successfully, so we can look at the results. Here we can see that we have a potential one-lane breach problem. We have one synchronized method inside our application. And here are other results. To learn more about the results, look at other tutorials for more detailed explanation of these results. The next thing we can do with our application, we can simulate the users and see the response times. So the easier path is to transform the extractor results and produce the overview model. The overview model describes our deployment, our application, how everything is connected in our application. We can modify the infrastructure layer, the platform layer, and then we can transform our overview model to produce the analyzer input. When we will have our analyzer input models, those are the repository, system allocation, resource environment, usage, and usage evolution. We will configure our analyzer and produce the results. So let's start with the extractor to overview transformation. Double-click the transformation button inside the workflow diagram. The wizard opens up, and we would like to create new overview model. Type in the new overview model name, press next, select our extractor result, basic configuration, and press the transform button. The operation completed successfully, so we can proceed. And now we have to select our external operation interface. Let's select one lane breach and press next. Now we have to select our deployment. So let's say that our cloud environment is Amazon Web Services. Our application will be deployed onto the generic application server, and we will have, for example, the clustered environment. Inside the resource configuration, we can select computing resource. So let's say that we will use T2 medium instance, Amazon instance, and we will have, for example, 3 instances with the load balancer. Press next button and finish. So now our overview model is produced and it is valid. We can see the structure inside the overview editor. We can see the architecture, the cloud environment, the infrastructure layer, the platform layer, the software layer. Here is our application. To visualize things better, we can open our overview diagram editor. So here is our Amazon Web Services environment. Inside it, we have our generic application server, and on top of this, our application, which was produced with the extractor. To view the properties of each component, we can open here on the right side the properties view. And here we can see the provided interfaces. Those are the interfaces that our application provides. And by clicking for example, the environment, we can see the infrastructure layer, our deployment. It is AC2 infrastructure, the platform layer, and our software. For example, here we can change our deployment. Previously, we selected T2 medium instances. We can change those parameters here. For example, we can set that we have 4 instances. So now I can save our overview model. And I think we can produce with the transformation from the overview model to the analyzer input. I will close now those editors we have opened previously because we don't need them anymore. So, okay. Start by pressing the transform button inside the workflow diagram. Here we would like to transform our overview model. Okay, we can type in the name of the new analyzer input alternative, select our overview model, and press finish. So now our analyzer input alternative is produced. We can see it inside the Explorer, CloudScale Explorer view. Here is our analyzer input. Those are the input models. And we currently don't have any configuration yet. But before we can proceed, we have some problem with the repository model, as we can see inside the workflow diagram here. So we can now validate our repository model, and we can see that our collection data type must be set. So let's expand the repository model, and here we can see that we must set the data type. Select string, and now we must save the alternative. These 2 arrows here indicate that the input alternative is in dirty state, so we have to save it. So now everything is valid, and we can proceed to the next step, which is configuring the analyzer configuration. We can again press the configurations buttons here, or we can double click the plus button inside the analyzer configuration sections. Now I will double click here, select the input alternative. We have only one, so we can press next, and here we can select what we would like to measure. We have three different options now: the normal configuration, the capacity, and the scalability. The normal configuration is the most time consuming because with the normal configuration alternative, we can measure the response times, the CPU utilizations, the bandwidth, and the costs, and other parameters. The second thing is the capacity alternative. With the capacity alternative, we can measure the system capacity, and with the scalability alternative, we can measure the system scalability. So for the purpose of this example, I will select the capacity alternative, so we will measure the capacity of our system. Press next, type in name, and the capacity configuration is automatically created. Here inside the basic settings, we can set the minimum number of users, which is 1, and the maximum number of users, which is 100 by default. Inside the measuring point, we can specify what we want to measure. So we are measuring our response times with the default usage scenario. We can select different usage scenarios inside the basic settings. You can see it here, but right now we have only one usage model. So we can select only that one. We currently aren't using the usage evolution, so here do not use usage evolution option is selected. We can fine-tune the monitors. The monitors are binded to the measuring points, as we can see here. This monitor is binded to this measuring point, and we can specify here how we would like to measure the usage scenario. For example, here we have the response time, but we have all different options to select here. For example, user capacity, resource demand, waiting time, response times, utilizations of active resources, power consumptions, and all those different things. Then we can specify how we would like to filter those results. Here we have selected the arithmetic mean, but we can select, for example, harmonic mean or the geometric mean. The next step is service level objectives. Here we can specify our minimal requirements. So these service level objectives are binded to the monitors here. And because we are measuring the response times, we have to set the upper bound. And let's say that our requirement for the response time is 1 second. So now we have to save our configuration alternative, and we can proceed to the analysis. So press run button here, and the simulation is started. The results were produced successfully, and we can see them by pressing the results button here. So these are our results. The system capacity is 100 users. This is because we have set inside the configuration that the maximum users is 100. So this means that our system can handle 100 users minimum. As I said before, the results currently don't make sense because when producing the extractor result, one manual step is required. I can show you again the repository model. Here are the service effect specifications, which are currently empty. So this means that every operation inside our example project uh, consume 0 resources. But we currently don't have time to measure those methods, how much time they consume, and so the results in the analyzer are, you can see here the response times are very, very short. To see the actual results of this minimal example project, you can create the example project by pressing by right mouse button here, selecting new and CloudScale example project, and here we have our minimal project which is configured and everything is already done. I have it here. Right now I will close those editors because we don't need them, and I can show you our extracted result. So here we have our service effect specifications. To learn more about each tool, we have prepared separate screencast for each tool. So now thank you all for watching and goodbye.